Hey, what's going on, guys? Welcome back to another video. Today we're going to be talking about weighted average and weighted mean, same thing. Before we get into the equation for the weighted average and, some problems, I want to talk about average in general, or mean. Mean is written by mu, so mu is equal to the sum of x divided by the number of terms. So that's mu, that's sum, and that is number of terms. And this is the general equation for an average or a mean in a population, that is. When we're doing average or mean in a sample, we use x with a line on top of it just like that. But it still remains the same equation. Sum of x over n, just like that. And whether or not you're actually familiar with this equation, this is something we do in our heads without even realizing it. So let's just look at an example real quick. If I told you that I'm driving a car and I drive at the following speeds: 70, 76, 82, 63, and let's say 50. And I asked you, what is my average speed? In your head, what you do is you add them all up and you divide it by 1, 2, 3, 4, 5, right? That's it. That's what it's saying. It's saying the sum of x, so 70 plus 76 plus 82 plus 63 plus 50, all this divided by 5. And then from here we get our answer. So this is the general equation for mean when it comes to a population. Now, when we talk about a weighted mean or a weighted average, the equation changes up a little bit, but the understanding behind it's still there. So let's take a look at an example. So when we talk about a weighted mean, we want every value to hold a weight to it. And I'll explain what that means in a second, but real quick, let's write our equation. So we're going to use x with a bar because a weighted mean is it's a sample mean, it's not a population. You don't need to worry about that too much. I might cover it in some other videos. But we're just going to use x bar to annotate it. So x bar is equal to the sum of the weight times the value divided by the sum of the weight. Just like that. And a lot of you might be asking, well, what's the weight? What's all that stuff? And let's just jump into an example, and I hope you understand. So example 1. Let's say you're in a class and an exam is worth 30% and everything else is worth 70%, for example. So let's just write our weight. So 70% and 30%. Those are our weights in the class. An exam holds a weight of 30% and the rest holds a weight of 70. Now, let's say before the exam, you were averaging 72. Let's go with that. So you were at a 72% before the exam, and let's say your teacher reached out to you and told you, hey, on your exam, I could tell you got a 95%, for example. 95%, just like that. So here we already have our values. We have everything we need to find our new average. And let's just use it. So x bar equals, so this means weighted average with like a little w subscript. So our weighted average is equal to the sum of the weight times the value. So let's do the first one. Now, when it comes to weight, as long as you're using consistently the same weight throughout, it doesn't matter. So what I mean by that is I could use a weight of 70 and 30, or I could use a weight of 7 and 3, or 0.7, 0.3, anything, as long as it's consistent. I can't use a weight of 70 and 3 because that's inconsistent. As long as you keep your units consistent, it'll all work out in the end. So I'm just going to go with 7 and 3. So weight, so 7 times x. So 7 times 72 plus, so W2, or our second weight, is 30. So I'm going to use 3 times 95, just like that. And now we're just going to find the sum of the weights, so 7 plus 3. just like that. And from here, it's just math. We just simplify. So real quick, pull out your calculator. 7 times 72, 504. Plus 3 times 95, 285. All this over 10. And we get 78.9. So in this situation, you would finish the class with a 79% average. And that's how you calculate it. And now it can get a lot more like complicated, whatever. But when it comes down to it, you're just following the same formula. You could have a lot of values, but the formula stays the same. So here in this situation, we actually went up basically 7% by getting a 95 on our final exam. Let's jump into example number 2. So here we have example number 2, and I'll explain what's happening. So you're in a class, and your whole class mark is worth 70%, everything up until the exam and summative. Your summative is worth 15%, and your exam is also worth 15%. I'm asking you, what do you need to get on your final exam to finish the class with a 92% average? Okay, so we also need some values. So let's say for the 70% portion of the class, you had an 89, for example. So I'm just going to write W so you understand that this is weight. Let's say you had an 89 on the 70% portion of your course. Now on your summative, let's say you had an 86. Okay, just like that. And finally, on your exam, what do you need to get a final grade of 92? So this one's a little bit different, but it's the same concept. So first, let's write our equation. So x bar is equal to, we have, I'm going to use actually like 70s and 15s this time instead of 7 and 1.5. We have 70 times 89 plus 15 times 86 plus 15 times, I'm just going to write, I'm going to use the variable x. X for exam. All this over the sum of the weights. So 70 plus 15 plus 15, we just know it's 100. Just like that. And we also know what x bar is, or the mean. We want the mean to equal 92. So just like that. So 92 equals this. And from here, it's just basic math. So multiply 100 by both sides. So we get 9200 is equal to 70 times 89 plus 15 times 86 plus 15 times x, just like that. And sorry, it's a little messy. That's just because I'm rushing. I don't want to make this video too long, but let's just keep going. From here, we simply subtract these two values, and I'm just going to skip right ahead and do that. Okay, so we get 9200 minus 6230 minus 1290 is equal to 15x. And real quick, so 9200 minus 6230 minus 1290, just like that. We get 1680 equals 15x. So just divide both sides by 15, just like that. And our final answer becomes 112. Now, can you get 112% on your exam? No, it's not possible. The highest you could possibly get is 100. So sometimes it's important to look at planning out like your goals in the course beforehand. If you wanted to finish this course with a 92, maybe you would want to have done a little bit better on your summative. Maybe just like the rest of the course, I don't know. But we can't finish the course with a 92% given, everything we've done so far. Now, we can, however, solve for the highest we can get if we get 100% on our exam. And that's simply just by subbing in 100 equals x. So I'm just going to do that real quick. Okay, so all I did here was just sub 100 equals x. So if I get 100 on my exam, what's the highest I could finish this class with? And now I'm just going to solve it. So x bar equals 1,290 plus 6,230 plus 1,500 divided by 100. We get, let's see, 90.2, just like that. So this tells us that, okay, if I bomb this exam, if I get amazing on this exam, I can finish my whole course with a 90.2% final grade, just like that. One more example. Okay, so our final example, this is a situation where we're looking at that 170%. So let's say you have a course, math, for example, and you have 1, 2, 3, 4, 5, 6 units. Unit 1 is weighed 16%, Unit 2 is weighed 21, 3 is 39, 4 is 17, 5 is 5, and Unit 6 is weighed 2%. And these are the marks that you achieve on those units. Let's say this whole thing is that 70% of the course. Just like that, okay? And this is like a two-step question. So first things first, we need to calculate our average, our weighted average, given these marks. So let's write our equation. X bar equals the sum of the weight times the value divided by the sum of the weight. Perfect. And I'm just going to skip ahead and get the final answer, and then I'll come back. Okay, just like that. So our final grade, given, our final course grade of the first portion is a 94.87%, just like that. So I'm just going to write that. So 70% of our final grade, and we achieved a 94.87%, just like that. So the second part to this question asks, okay, so let's say we have an exam worth 30%. Just like that. What do we need to get on our exam to get this mark up to 100? So again, simple. We want our final mark to be 100, so 100, or the weighted average equals 100, is equal to, we do 70 times 94.87 plus 30 times and x, and we are solving for x now. All that divided by 70 plus 30, just like that. So this is 100, we know that, and let's multiply both sides by 100. So we get 10,000 equals 70 times 94.87 plus 30x, just like that. And now we just want to subtract this term from both sides. So we get 3359.1 equals 30x, just like that. And now just divide both sides by 30. So bop, bop, and we get, yikes, 111. X equals 111.97, just like that. So is it possible for us to get 100% on our final exam? Or sorry, as our final grade? No, it's not, because we can't get 112% on our final exam. However, this changes a little. I know it seems, this is the math behind it all. So I know this is like basically a 95, and you're thinking, oh, I could easily get, 100% as my final grade if I, just bang this exam. But when it comes down to it, like, you can't. And it sucks because sometimes you'll be like really high, and even if you get 100% on your final exam, you can't fully get 100% as a final mark. But that's it. That's the math behind it. Anyway, guys, hope you enjoyed the video. Hope you learned something new. Hope you learned how to calculate your averages, maybe anything like that. If you enjoyed it, please share it, I guess. If it helped you out, share it. With that being said, hope you guys have a great day.